Hello and welcome to this video on CICD with GitLab Kubernetes Runners and Devops tools. In this video, we will explore how to implement continuous integration and continuous deployment using GitLab, Kubernetes, and various essential DevOps tools for our Node.js application. Whether you are new to DevOps or a professional, this video is for everyone, and I will strongly suggest to practice this for in-depth learning. Let's get started. This is our CI/CD pipeline, where CI stands for continuous integration and CD stands for continuous deployment. CI refers to the practice of integrating code changes into a repository frequently, whereas CD refers to the next step, where code is automatically deployed. In our pipeline, we have stages starting from where our code is pushed to GitLab, which will be our source repository, and then the first stage is SAS, which means static code analysis, then followed by second stage, which is unit test. Third, we have build stage, where we will build the Docker image, and then the fourth stage, which is image scan. It basically scans the vulnerability on the image. Next starts the CD part, where we have three environments: dev, test, and prod. We start with deploying to dev with dev deploy stage. Then we promote the image to test artifactory with test promote stage, and then deploy it using test deploy stage. Similarly, we have for prod promote and prod deploy stage also. Going forward, I am going to discuss about the tools you can see on the screen for each stages and the implementation as well. So sit tight. Lot of topics are covered all through the video, but here are the key points like we are going to discuss about GitLab Kubernetes Runners for this CI/CD pipeline. Then we will implement KAS Agent. KAS stands for Kubernetes Agent Server. Then we will discuss the tools used in our pipeline. We will also walk through the pipeline stages and end-to-end implementation. Before moving to the actual pipeline, this is how the GitLab Runner and KAS Agent setup will look like. In the picture, you can see that the GitLab Runner is running as a pod on Kubernetes on the dev cluster. I will deploy it on dev cluster only, but you can use multiple runners for each environment also. The main runner basically spins up temporary pods for execution of jobs when the GitLab CI pipeline triggers it. Okay, next I will deploy KAS Agent on each of the three clusters: dev, test, and prod. Going forward, you will see how the KAS Agent helps us in deployment. By now, I have mentioned many times the word GitLab Runner. Let's understand what is it. It is an application which processes the builds for GitLab CI/CD. Think of a server or container which basically executes the stages you define in the GitLab CI. It supports multiple executors like Docker, Kubernetes also. It allows you to run job in an isolated environment, and once the job is done, the runner container is also gone. Now let's understand why we use Kubernetes Runner. Kubernetes Runners offer several key benefits for your CI/CD pipelines. First, scalability. With Kubernetes, you can easily scale your CI/CD jobs to meet workload demands, ensuring that your pipeline can handle increased activity without bottlenecks. Next, isolation. Each job runs in its own Kubernetes pod, providing a clean and isolated environment. This guarantees that jobs won't interfere with each other, resulting in more reliable builds. Finally, resource management. Kubernetes efficiently manages the underlying resources, optimizing both cost and performance. Now let's configure our Kubernetes GitLab Runner. I am creating a new project in GitLab. Let me name it as CICD-EKS. And rest all settings I am keeping it as it is. I have clicked on create project. Let me clone this project on my local. Next, I am going to follow this README. I have copied the command to create the namespace for our GitLab runner. But before running it, let me update the KubeConfig for dev cluster. Next, I have copied the command to set the context of the GitLab runner namespace. Next, I need to add the GitLab runner health chart. In my case, it's showing already exists as I have this on my local system. Next, I need to create this values.ml file for configuring our GitLab runner. This values.ml file I will use while deploying the GitLab runner on our dev Kubernetes cluster. If you see, we need two major inputs here. One is GitLab URL and other is runner token. But where we will get this? For that, we need to create a runner for our project. In settings, navigate to CICD, then runners. Here we have an option for new project runner. I have clicked on it and it's asking for tags. I am using tag as k8-runner and rest as default. This tag only we will use for all our jobs. Next, we got this page which is asking for registering the runner. I am going to copy paste this GitLab URL into my values.ml and then the runner token also. Now our values.ml is ready for deployment. So let's deploy it using Helm. Let me copy the command. Okay, no such file or directory. So I need to update the correct path here. I should remove this GitLab runner thing. Perfect. Now let's run it. Okay, we can see that our runner is deployed. Now let's view the runner on the GitLab UI. Let me click on view runners. Let's leave. Okay, I think I need to do a quick refresh. Fine. And we can see that our K8 runner is online. Next thing is we need to give permissions to our GitLab runner to access our Kubernetes objects. And for that, I am creating cluster role and cluster role binding. You can locate these files inside GitLab runner folder. I have mentioned the GitHub repo URL under the description section. So I already have this file. I'm just going to apply both these files. Cluster role is done. And next is cluster role binding. Perfect. The GitLab runner is ready. The GitLab Kubernetes Agent or KAS is a powerful feature that enables secure and efficient integration between GitLab and Kubernetes clusters. With the KAS agent, GitLab can directly deploy applications to your Kubernetes clusters, streamlining the deployment process. Additionally, the KAS agent provides enhanced visibility into the Kubernetes cluster right from GitLab. Now let's configure the KAS agent. I am under Operate and then Kubernetes cluster. I have clicked on Connect a cluster. Here it's asking me for selecting an agent. I can see these agent names because I had this agent earlier, but in actual these agents are not available now. If you are doing it for the first time, then you won't get any agents to select. Just type any good name for your agent and click on Register. Then GitLab will give you this command to deploy the KAS agent on your KH cluster. Copy this command and run it against your cluster. The command basically adds the repo and update it and then deploys the agent. I am updating the KubeConfig for my dev cluster. Okay, the command looks successful. Now let's verify if the agent is online or not. So our agent is live now. I am creating agent for test cluster now. I need to update the kubeconfig for test cluster and perform this deployment also. So test. Now my kubeconfig is updated. So our test agent is also live. Next I am creating for prod cluster. So prod agent also is complete. Let's verify. Perfect. We have deployed all the three agents. Now we need to create user access for the agents we configure. And for that, we need to create a config.yaml file inside .gitlab/agents/agent name folder. I have updated the README to fix the typo. So I have named it as dev agents because our agent name is dev agent for development. Here in config.yaml, I need to update the project ID for which I am going to give access to the agent, and I am giving access to the group as well. So the agent, the project name is not this one. It should be CICD EKS. Right. Let's go to projects. So inside my group, I have two projects. I need to give access to CICD EKS only. So this is the path. Let me copy the name. And inside group /CICD EKS. And here it will be Nanditech Packs because under this group only, I have this project. Similarly, I need to create configs for test agent and prod agent. So in total, there will be 3 subfolders inside .gitlab/agents folder. Perfect. I am just putting the folders in my project repository, CICD case. All done. Now let's create environment with our KAS agents. Under Operate, there is an option for environments. Then click on Create Environment. I am giving name as Development and agent I have selected Dev Agent. Under Namespace, I want to select the namespace where I want to deploy our app. But it's not showing because we have not created any namespace for our app deployment. Let me create a namespace named Demo in Dev, Test and Prod Cluster. So I'm back in the terminal where I'll be creating the namespaces. So I'm creating the namespace named as Demo. Let me update the KubeConfig for test cluster and create the namespace here also. Similarly, I need to do for prod cluster. So the namespace creation is done. Now let's check whether it's showing on the GitLab UI. So as of now, it's not showing. Let me change this and test. So it's not showing. Let me refresh it then. Dev agent. Okay. Now it's showing. Right? Yeah. Let me give the name. Development. Save. So our development environment is created now. Similarly, I am creating test environment with test agent and production environment with prod agent. Same steps. Test agent here, and under namespace it should be demo. Save. Using these environments in our pipeline, we can choose where we want to deploy, right? So all our 3 environments are created now. Now let's add some variables that are required for our pipeline to execute. I am navigating to settings, under settings CICD and expand variable section. I am adding new variable name cube_context under environment. Let me verify the variable name cube_context. Okay. So under environment, I am choosing development. and value of this is the project directory colon agent name. Agent name is dev-agent, so it should be nanditech bytes / CICD EKS colon dev-agent. Similarly, I need to update for test and prod environment as well. I have created one Docker Hub password variable for my pipeline, right? I haven't shown this on the video because I don't want to share the password, right? But the steps are similar. You just need to update the Docker Hub password and the key. So this is for the test. Let me copy this. This variable we are going to use in our deploy stage. It will be used for setting the context against our cluster in which we are going to deploy, right? So we have created 3 KubeConfig variable for each of our environments. Okay, hold on. I think I have mistakenly updated slash instead of colon. Let me fix that for all. So it should be colon, not slash. It should be colon agent name, right? So let's verify test is done correctly. Okay, with this part is complete. Next, I'm going to discuss the tools used. For static code analysis, we will be using MegaLinter. MegaLinter is a powerful automated tool designed to enforce code quality standards across your projects. It does this by running a wide variety of linters, formatters, and static analysis tools. MegaLinter supports multiple file types and languages, including Java, Terraform, YAML, Python, Bash, PHP, and many more, making it a versatile solution for teams working with diverse technologies. Unit testing is a crucial part of a software development, where individual components of the code are tested to ensure they work as expected. In this pipeline, Mocha serves as the testing framework, while Chai provides powerful assertion capabilities to verify that the outcomes of the code matches the expected results. Mocha is a flexible and feature-rich JavaScript test framework, offering a solid foundation for writing and organizing tests. Chai, on the other hand, offering readable and flexible assertions for any testing scenario. It integrates seamlessly with Mocha, making it a popular combination for unit testing in JavaScript projects. Kaniko is a tool designed to build container images directly from a Docker file within a container or Kubernetes cluster. One of the Kaniko's key advantages is that it doesn't require a Docker daemon, making it an ideal choice for CI/CD pipelines that use Kubernetes as a runner. This means Kaniko can securely and efficiently build images in environments where the Docker daemon is not available. I have a dedicated video on building images with Kaniko on Kubernetes. You can watch that if you are interested to learn more about it. Security is a top priority in modern CI/CD pipelines, and Trivy plays a crucial role in maintaining that security. Trivy is a comprehensive container scanning tool that helps detect vulnerabilities in both the operating system and applications. In addition to vulnerability detection, Trivy also performs compliance scanning, ensuring your containers meet security standards. It even allows several filtering so you can prioritize and address the most critical vulnerabilities first. Helm is a powerful package manager and deployment tool for Kubernetes. It simplifies the process of defining, installing, and managing Kubernetes applications by using Helm charts, which are reusable version control packages. In this pipeline, we will be using a single Helm chart to deploy the application across multiple environments, dev, test, and production. This approach streamlines the deployment process while maintaining consistency between environments. Now let's walk through the project repository. All the source code like application code, Docker file, and Helm charts, unit testing code are inside this example folder, right? So inside the example folder, if you see, there is a Helm repository. Inside the Helm, hello app, templates, we have deployment.yaml file and service.yaml file. The deployment.yaml file, you can see the container port is mentioned at 3000. And in the service.yaml, the target port is also 3000. And all the values are being fetched from the values.yaml file. So this is the values.yaml file. And since we are going to deploy in dev, test, and production, right? So there are three separate dev underscore values.yaml file, prod underscore values, and test underscore values.yaml file. These three YAML files consist of details related to development, production, and test environment. Inside dev values, if we see, node environment is development, right? Repository is different. Similarly, for prod, the node environment is production. Repository is Devops 091 prod. And for test underscore values, you can see Devops 091 flash test. Test folder, we have app.test.js, which consists of the unit testing, right? And outside this, you have a Docker file. This Docker file is being used for containerizing the application. It's a simple Node.js application Docker file. We have used Node 16 Alpine image as a base, then setting the working directory to user source app, and copying the package.json and running npm install dash production, right? And we are exposed port 3000, and we are just running the server.js file with the help of cmd. Here is the source code server.js. It's a simple hello world code. And here is the package.json. Next thing we have is .megalinter.yaml. This is basically for the SAST part. It consists of we are scanning the Docker file, JavaScript, YAML. And since I'm doing a demo, I have disabled error linters for YAML lint, JavaScript standard, and YAML v8 var, so that I can move ahead with the scanning. And if the scanning is fail also, I can move ahead with the stages, right? This is the screenshot of our GitLab CIML, where you can see we have defined the stages that we have discussed. Next, we include a predefined job for container scanning, which is brought in via the line include template. This template is provided by GitLab only. I have referred it from their document. Now, looking at the variable section, we define several key values that will be used throughout the pipeline. Dockerfile path points to the Dockerfile location inside the repository. Docker Hub username and Docker Hub repo are set for pushing the built image to Docker Hub. Image name creates a unique image tag using the Docker Hub details and the pipeline ID. Helm path specifies the location of Helm charts for Kubernetes deployment. Creates namespace defines the Kubernetes namespace where the application will be deployed. Project name sets the name of the application. In our case, it's Hello App. In this section, we defined a MegaLinter job, which is part of the static code analysis stage. This job is tagged with KAS Runner, indicating that it will run on the Kubernetes-based GitLab Runner, which we have configured. We are using the MegaLinter latest Docker image to run MegaLinter. The script section runs the entry point script. The real power of this job comes from the MegaLinter image and its configuration. The variable section includes default workspace, which sets the path to the workspace as $CI project directory, pointing it to the project directory where MegaLinter should run. Default branch is set to main, meaning that this branch will be the default target for this linting process. Finally, the artifacts section ensures that a report is generated and saved. These artifacts located in project directory and will always be stored for up to 1 week. In this section, we define the unit test job, which is part of the test stage. In our CI/CD pipeline, this job will also use our KAS runner. We use the latest version of the Node.js Docker image, Node Latest, which provides the necessary environment for running our JavaScript tests. Before executing the main script, we have a before script that performs two key actions. First, we change the directory to example using the command cd. This sets the working directory to where our application code resides. Next, we run npm install to install all the necessary dependencies defined in our package.json file. Additionally, we install char, a popular assertion library for Node.js, by executing npm install char --save--dev. This package is essential for writing readable and flexible assertions in our tests. In this section, we define the build image job, which is part of the build stage of our CI pipeline. Like the previous job, it is also tagged with our KAS runner, indicating it will execute on the Kubernetes runner. We use the Kaniko executor image specifically from the GCR.io Kaniko project executor version 1.23.2-debug. The script section consists of two main commands. First, we create a Docker configuration file, config.json, that contains the authentication details for Docker Hub. This file is saved to the path /kaniko/.docker/config.json. The username and password for Docker Hub are pulled from the environment variables Docker Hub username and Docker Hub password. Ensuring secure access, the second command runs the Kaniko executor with several environment parameters. --context specifies the build context set to the project directory. This is the path that Kaniko will use to locate files needed for the image build. --docker file points to the Docker file to use for building the image, constructed dynamically from the project directory and the Docker file _path variable. --destination defines where the build image will be pushed, using the image _name variable we defined earlier. This setup enables seamless and secure image building and pushing directly from our CI/CD pipeline. In this section, we define the container scaling job, which is part of the scan stage of our CI/CD pipeline. This job is executed by the template that we have included from GitLab. I have mentioned about this earlier. We begin by setting up essential environment variables that are required by the template during the scanning process. The variable cs_image is set to the value of image name, which references the name of the image we want to scan. This image name is dynamically generated in previous stages of the pipeline. The cs_registry_user variable is assigned the value of Docker Hub username, providing the username required for authentication with Docker Hub. Similarly, cs_registry_password is set to Docker Hub password, which holds the password needed for Docker Hub authentication. In this section, we define the dev deploy job, which is part of the dev deploy stage in our CI/CD pipeline. This job uses the Docker image Helm kubectl :3.9.1, which includes both Helm and kubectl tools for managing Kubernetes applications. Before executing the main script, we have a before _ script that sets the Kubernetes context by using the command kubectl config use -context and agent underscore context. This ensures that the deployment occurs in the correct Kubernetes cluster and context. The main script section contains a single command that uses Helm to upgrade and install our application. The command structure is as follows. Helm upgrade is used to upgrade an existing release or install it if it is not present. The -- namespace option specifies the Kubernetes namespace in which to deploy the application using the variable kh namespace. The -- install flag indicates that if the release does not exist, it should be created. The -- values options point to YAML files. One is values.yaml, which is for setting default values, and another is dev_values.yaml for environment specific values. These files define configuration settings for our application during deployment. The -- set image.tag equals to CI pipeline ID option dynamically sets the image tag to the current pipeline ID, ensuring that the deployment uses the latest image built in our CI process. Finally, project_name specifies the name of the release, and Helm path provides the path to the Helm chart. These jobs effectively deploys the application to the development environment. Similarly, we have these stages for test and production as well. In this stage, we are using the same Kaniko stage used in build stage but with a minor modification, which allows us to pull the image from dev artifactory and then tag and push it to test artifactory. Similar stage is there for prod artifactory as well, where the image will be pulled from test artifactory and then tag and pushed to prod artifactory. The modification here is that we have added one more echo command which tells the Kaniko executor from where the image should be pulled, and -- dockerfile option is set to dev/standard, and for the -- destination we have updated it to point to test artifactory for test promote stage and to prod artifactory in prod promote stage. Okay, I think we have discussed a lot on each of the stages. Finally, let's execute the pipeline. If you are still there, then please do like, share and subscribe to the channel. Let's start with the execution of pipeline. For this, I am going to copy the example folder to my project repository. And let me copy the MegaLinter.yaml file and paste it on my project repository. And also let me delete this values.yaml for the GitLab runner that we have created earlier, as it is no longer needed now. And let me also copy the GitLab CI file to the project repository. Let's quickly check if all the stages are defined. Fine. Now let me get inside the repository on my terminal and add the files to the Git and push it to GitLab. So cd CICD EKS, git add, git commit -m, I am using main branch for this demo. Ideally, we don't make direct changes to the main branch. Instead, we create a feature branch and then push the changes. Okay, now let's see in GitLab if our pipeline is triggered or not. So as you can see, our pipeline is not triggered yet. But let's recheck again. Okay, the pipeline is triggered. So we can see that all the stages are being shown here on the UI. I think the runner is in pending for state here. So let's check on our dev cluster about the status of our runner pod. kubectl get pods -n. Our namespace for the runner is GitLab runner. So okay, the temporary runner is getting initialized. Let's give it some time as it is the first time. Meanwhile, let's verify the logs to check if this is the pod we are waiting for. Let me copy the name. We should get the same name on the logs. Right, so you can see that the same name, the logs are also referring to the same pod. Okay, our first stage, which is static code analysis, is completed, and unit test stage is triggered now. Let me do a quick refresh. So the pod is in pending state. So the stage is completed. In the output for npm test, we are getting the output as hello world, and it's telling one passing. Perfect. Now let's see the build stage. The build stage is running. Okay, it's completed. So let's verify the logs. So you can see that the image is created and pushed. Let's cross verify by checking my Docker Artifactory for dev, which I named as Nanditech bytes. So this is the image is tagged with the pipeline ID. Let me open Docker Hub. It should be pushed to Nanditech bytes. So if we verify the tag of the image, it's showing our pipeline ID. So it means the image is pushed via this pipeline execution. Perfect. Interestingly, our pipeline failed in dev deploy stage. Let's check the logs to find the issue. So here in the logs, I can see that the pipeline failed at the before script section. The command kubectl config use context $agent underscore context is getting failed. Okay, the issue is with the variable we have defined. We have defined variable name as kubeContext instead of agent context. So let's recheck in the variable section. Variables, expand. So yes, it's cube underscore context and not agent underscore context. Okay, now let's update the correct variable in the pipeline. and then push the updated changes. Let's replace this. Updated variable, git push origin main. Let's look at the pipeline now. Build pipelines. Okay, it's triggered. I am going to pause the video and will resume when the pipeline is completed. Okay, our dev deploy stage is successful now. But before that, let's see the logs for scan stage. You can see Trivy is telling us that there are many vulnerabilities in our image. But for now, let's focus on our execution as it's a simple hello app for demo only. Coming to the dev deploy stage logs, we can see that the app is deployed to dev. Let's check on the terminal. So now I am in the dev cluster. Let's see the pod. It's running. Let's get the service. Let's copy the DNS. So this is the load balancer DNS and we are getting hello world. Perfect. All the stages for the pipeline are also completed. Let's check the promote stage. Test promote. So here you can see that the image is retrieved from dev artifactory, which is Nandi tech bytes in our case, and tagged with test artifactory name and pushed to the test artifactory. Let's verify the test artifactory on Docker Hub. It should be tagged with the same pipeline ID. Yes, so the pipeline ID is same, right? It was pushed 3 minutes back. So promote test is also done. Okay, now let me show you our app directly from the GitLab console. As you can see, directly view the resources from inside our GitLab environments. All thanks to the KAS agent we configured. So under inside production environment, you will be able to see the pod demo namespace. Let's verify what test environment. Here also we have hello app. Thank you for watching the video till the end. Please do like, share and subscribe. I have shared the GitHub URL on the description. Please try to implement it and do let me know under the comment section. If you have any queries, please do share. Thank you.